the monitoring that's been done across the province now for well over 12 years for stream condition and riparian condition as a result of harvesting and logging and forest activities. And so the question has been, well, are the practices that are currently employed on Crown land in BC effective at maintaining the biological integrity of streams and riparian ecosystems? And so this is this program here. What, if you recall, we did a little bit of this in the field, and then in the class we worked through an example. If you remember, it was like that. I have it posted on Learning Hub. Like there was like 18 sheets, and there's 15 questions that you have to answer, and there's all these different indicators essentially that we're trying to track. And so examples of those indicators include signs of channel bed disturbance. Oh, someone's got their mic on. Oh, here. Jason, can you try? Oh, Kayesha, I'm going to mute her. She's not listening to me right now. Kidding. It's hard. We've all got like families and people in the background, or not. So anyways, there's all these different indicators. So there are things related to fish cover, moss abundance, or sediments, or wind throw. So there's all these different sort of indicators that are being tracked and monitored. And the process involves a whole suite of measurements in the field. And so the program itself has been used as a system to monitor how effective we are with our riparian management practices in BC. And they use these indicators to provide a condition rating, and based on whether or not you pass or fail these different indicators. The program has been in existence since the early 2000s, and it provides annual monitoring on streams 1 to 3 years post-harvest across BC. And so we went out into the woodlot, and we had started at the top of, if you remember, we looked at Nygaard Creek down here, and then we hiked up Heckle and Jekyll. This was this mountain bike trail in Brown. And then we walked over, and I sent you guys into the Windthrow to have a look at the channel below. But actually what we did do was we monitored above the road. So road 21 here is a brand new road that was built just a few years ago. And so we went above that channel and captured some data. So the protocol, I'm just going to walk you through some of the elements of the protocol. And this is the FREP monitoring protocol. One of the approaches, first of all, is that there are 6 point plots. So this sort of ties into some stuff that Wayne might be teaching you in measurements. So these are point measurements, and examples of what is tracked there, I'll go over in a second. But between them, we didn't do this in the field. Between each of these plots, there is a transect, and along that transect, this is where there are continuous indicators that are measured. And each transect is going to be 20 meters long. And throughout the whole length of your reach, you're also trying to look for a number of other different indicators throughout. And so this, for instance, are examples of the point indicators through the methodology. So moss was one of them, as well as the fine sands. Oh, this is where we did the percent shade. Remember when we stuck our hands up in a little circle and looked through it to look for percent shade to the south, to the east, to the west? And then, if you recall, you had to dip your net in the stream and count the number of benthic invertebrates, and again classify them. We didn't classify them based on this, but we classified them as to whether they were insects or what were the other classes? There we go. Invertebrate types. There were different invertebrate types. And also whether they were sensitive or not. And just as a reminder is that you could expect to see different proportions of different species. So stoneflies, caddisflies are examples, or mayflies or larvae, different proportions of those species depending on where you are in the watershed. So if you're more in headwater streams, you would expect to see a slightly different proportion of shredders and collectors relative to if you are further down in the watershed. And so this is just a sort of generalized model of how those species, the abundance of different types of invertebrates would change throughout the watershed. And there we go. So here were some of the different groups that we had to classify the invertebrates as, and here was the example, and we came up with, should just let you guys do this right now, but I'm just trying to cruise through here a little bit. But worth having a stab at this again. So how many different invertebrate types were there? Types referred to as, the snail is one type. 1, 2, 3, 4, 5. No, that doesn't make sense. Sensitive invertebrate types. That's what I'm getting wrong. Right. So we're just looking at the mayflies, the stoneflies, the caddisflies, riffle beetle larvae, clams, snails. Do we have all of those? I think we've got 7. You know what? That fancy pen is not working anymore. So worth going through here, and what I would encourage you, maybe what I'll do is I'll post it as one of our breakout sessions. You guys can go over this and see if you can do this on your own. Okay, now the continuous indicators, what those are is throughout each one of these transects, these 20-meter transects, there was a whole suite of different continuous indicators that you have to track. But they vary, the ones you have to track, depending on the stream type. So first step is to determine what is your stream type, whether you're a riffle pool, cascade pooled step pool, or non-alluvial. And some of those features include channel bars, disturbed banks, bare erodible ground, wind throw, etc. The other indicators were things that you're looking through out the whole reach. And so those indicators are outlined here, and there's some examples here, like the presence of deep pools, or riparian structure, or evidence of browsing or grazing, or quicksand was another one. It's in here somewhere. Here we go. Is the channel free of quicksand or quick gravel? So those are things that you're looking throughout as you're doing all your measurements, and you're checking these boxes if it applies, or checking no if it doesn't apply. And then the whole thing gets compiled to answer 15 different questions, and we did that in class, where you have to read through these field cards and determine whether your indicator is a yes, in other words, you've met the requirements for the channel bed disturbance, we're all good, or a no signals that there's a problem. And once you tally up all the no's, so if you got 13 out of 15 were all good, 2 of the indicators were problematic, that would rank the stream or stream reach as properly functioning. If you had 10 out of 15 were all good, so 5 of them were problematic, the stream would be ranked as functioning, but at high risk. And so this provides a metric and a measurement for the condition of streams following harvest activities. So the findings in 2018 from the Forest and Range Evaluation Program on stream condition and riparian environments was that in the province, S6 streams had the poorest functioning or risk, or at the highest risk of or were not properly functioning. So the red is not properly functioning, the yellow is functioning but high risk. And notice how essentially half of the S6 streams were ranked in that category. So what that would mean, if I'm just going to move back to the last slide, is that half of the S6 streams were in this category here. Half of them had at least 5, even over 6 of these indicators that were ranked as a no. In other words, they didn't pass on a number of these different indicators. And what they found was that it would differ based on, there was more issues on the coast versus in the interior of the province. And so here is the coast, here is the north-south of the interior. And what we found, or what I wasn't part of this, they found was that here were the numbers for non-properly functioning, or also properly functioning but at risk, where this is the amounts on the coast. And in the interior, those problems were not as significant. And the reason for that is probably because on the coast we have, first of all, way more streams. The terrain is way steeper and more challenging. And we get so much, if you remember your regional hydrology work, when you looked at the climate for the climate data, we have lots of rain on the coast, like way more rain in the interior. And because of that, it's just conducive to a lot more complexity when it comes to streams and hydrology and management. Part of the evaluation is about linking what are the factors that are driving the problems. So natural factors can be big drivers, right? There's natural variation, like we were talking about. There's flooding events that happen. Those have to do often more with climate and the stream function itself, its natural processes. So natural factors contribute to quite a bit of the impacts. But logging, especially on the coast, and logging activities are big drivers as well. So that was part of what the program is identifying. And when we look at some of the direct logging impacts, we can see how some falling and yarding is one of the biggest issues. And so by identifying this, we can improve. We can improve our practices, and that is conversations that are happening currently in the province. Okay, we talked about how there's different, although there are those sort of default RMA, RRZ, RMZ prescriptions, that there are variances that we can do depending on different scenarios. So here are the defaults. And my questions for you in class was, can you think of situations when we might deviate from this? When you as a future professional might make a call, a judgment call, to deviate from these default buffer widths. And so some examples we talked about was, first of all, our example at the Seymour River, where we have a box canyon through part of the stream reach. Here's the Seymour here. You can see how it's not confined. And this segment of the Seymour River is definitely confined in bedrock in the canyon. And that was an example where we could potentially decide to log almost to the edge, because the river itself was close to probably 50, 60 meters lower in elevation than the top of bank or the top of the canyon. And so this decoupling of the riparian ecosystem in the stream could be a scenario where we could possibly log to the edge. That being said, safety, slope stability are going to be important from a geotechnical perspective, important things to consider as well. Another example is wind throw. So depending on weather patterns, the species and the stability of the species, or the health of those trees, or even the superficial material, riparian management areas may not be stable and are perhaps best removed. And so here was a case study on Nootka Island on the west coast of Vancouver Island, where crazy storms come in, large wind events, high intensity